Over 100 years ago, a meteorologist named Charles Wilson wanted to see cloud formation up close. So he created a small structure that replicated the formation of a cloud, calling it a cloud chamber.
Aha!
However, when Wilson put his invention to the test, he stumbled upon a fascinating natural phenomenon. The chamber did create a cloud as intended, but he also noticed small clouds would occasionally form along trails that seemed to zip through the chamber. Wilson soon recognized this effect was being caused by ionizing radiation, and he had accidentally created a particle viewing chamber. Today, we're going to be scientists and create our own cloud chamber to witness the effects of ionizing radiation, just like Charles Wilson did. Our mission here at the U.S. Department of Energy, Office of Legacy Management, is to protect human health and the environment at sites that once played a role in our nation's nuclear defense. This mission includes the management and control of radioactive material, which is why we're diving into the science of radiation. If you want to make your own cloud chamber, check out the instructions linked below the video. An adult will have to purchase some of the materials and should accompany you during this activity. This is a science experiment, so safety is the most important part. You'll need gloves that can protect you from extreme cold and safety glasses. The base of your cloud chamber has to safely hold dry ice. First, put dry ice in the base and then cover with a thin metal sheet. The viewing chamber needs something absorbent, like felt, attached to the bottom. Soak the felt with ethyl alcohol and then flip it upside down and place on the metal sheet. Make sure to seal it with tape. Finally, place a heated pad on top of the flipped chamber. Cloud chambers function by creating warm and cold zones that affects the alcohol's phase of matter. At room temperature, alcohol goes through a phase change from liquid to gas. However, in the bottom of the container, near the dry ice, the alcohol gas condenses into a liquid. This creates a supersaturated environment, and in the darkness with the light shining on it, you can observe this manufactured cloud towards the bottom of our chamber. Cosmic rays from stars constantly bombard the Earth and can occasionally cause streaks of clouds or condensation to form within the chamber. Charles Wilson first observed these effects of cosmic radiation in his chamber, but for a more consistent viewing of ionizing radiation trails, Wilson began studying radioactive sources such as rocks like this one that contain various radioactive elements. We're going to observe what happens when we place different known radioactive objects inside the chamber, including Fiesta ware, Brazil nuts, and a banana. Consider pausing the video here to write down any questions or theories you may have and record your observation as we look at our different sources. You may be asking yourself, how or why are any of these things radioactive? Well, let's find out. Fiesta ware, a brand of dinnerware, was popular from the 1930s through the 50s. Its lustrous red color was crafted with a uranium glaze. Uranium is famous for its radioactive properties, so it shouldn't be surprising that anything crafted with it is going to be slightly radioactive. Uranium and its progeny isotopes emit alpha, beta, and gamma ionizing radiation, with alpha being the most prevalent. Alpha radiation is a positively charged particle consisting of 2 protons and 2 neutrons that have been ejected from an atom's nucleus. Alpha radiation only travels up to a couple inches, causing short, straight trails. For our next radioactive source, we'll look at something more commonly found in your home, like a banana. Bananas are a healthy source of potassium, which help prevent muscle cramps. However, a naturally occurring radioactive type or isotope of potassium, potassium-40, makes bananas slightly radioactive. Bananas primarily emit beta radiation. Beta particles are smaller and faster than alpha particles. They're negatively charged and easily affected by other charged elements nearby. You can see the difference in the trails they leave because they move in erratic patterns compared to the straight lines created by alpha particles. Beta particles can move several inches to many feet depending on conditions. Occasionally, long straight trails will appear that look like a bullet was just launched from the banana. This is caused by gamma radiation, which we will see better from Brazil nuts. Brazil nuts are a seasonal snack that contain the radioactive isotope radium-226. This is due to the deep root system of Brazil nut trees, which access minerals and nutrients deep in the soil not available to most plants. Gamma rays are waves of energy that travel far and fast, quite different from the particles of alpha and beta radiation. Like alpha and beta particles, gamma rays can ionize the atoms that make up the air in the cloud chamber, leaving distinct trails for us to see. Now that we've taken a brief look at different radioactive sources in our cloud chamber, can you think of any uses for ionizing radiation? What are they? With a parent's help, can you think of and test other common items at home to see if they emit ionizing radiation and why? Science helps us uncover the mysteries of natural phenomenon like radiation. We hope you're inspired to learn like a scientist on the STEM with LM webpage.